We're jumping into chapter 12 and we're going to start considering when we have two or more variables and if there's a relationship between those variables. And we're also going to see, okay, well, if we want to fit something to that relationship, can we do that? So we're going to talk about this relationship or correlation between variables. Do not make a mistake of saying that it's cause and effect. Cause and effect is something else. This correlation effect is another thing. For example, if you're a mountain climber and you climb up higher and higher and higher, the height of the mountain is something different than the oxygen that's in the air. The oxygen in the air, the higher you go up, the less oxygen there is in the air. So that is a relationship. The higher you go, the less oxygen there is. But they're separate variables all by themselves. But together they make this relationship. So that's what we're really going to focus in on, is the relationship between two or more variables. There are two types of data that we're going to be described is bivariate, bi meaning two variables, and multivariate, which just means many variables. Could be 3, could be 4, could be 5. So in this case, we'll be dealing with the simplest form, which is a line. When you have two variables, that creates a line. So we're going to be calling it linear regression. All right, let's jump in. Linear regression. Linear regression is just a line. Remember the good old y equals mx plus b? That's all we're dealing with. We are going to call the variables a little bit something different. Y equals a plus bx. But you can still think of it as y equals mx plus b. It doesn't matter what letters you use. It's still the equation of a line. Our x is our independent variable and y is our dependent variable. And typically we choose our x values to plug in and then find our y. So here's a couple of examples of linear equations. You have probably seen lines before. Again, this was kind of, it's set up slightly different in terms of it's not y equals mx plus b, but we could translate it to that. So y equals 3 plus 2x, we could translate it to y equals 2x plus 3. And y equals negative 0.01 plus 1.2x. So these are straight lines. It is an equation of a line. We just, for whatever reason, this book likes to set it up a little bit different than a line, than our normal y equals mx plus b. If you have had experiences graphing lines, that's wonderful. If you're using the TI-84 will graph it for us. But a graph of a line, y equals negative 1 plus 2x, I want to just point out some very key points to this. This negative 1 is the y-intercept. It's where it crosses this y-axis. So we have our y-axis, we have our x-axis, which are these two dark lines. Where it crosses the y-axis is called the y-intercept. So it crosses is at negative 1. These are all the negative numbers, those are all the positive numbers. And the 2 that's in front of the x is our slope. It's how steep our line is. If it is a positive slope, like positive 2, it is going to go upward. If it is a negative slope, it is going to go downward. So that is a quick refresher about lines. Now let's take a look at this particular image. Is this a linear equation? If so, why or why not? Well, first of all, that is a line, but it's not a straight line. And if it is not a straight line, because it has a curve right here, if it is not a straight line, then it is not a linear equation. This could be a multitude of different types of equations. Because of the curve I'm going with, it's probably a quadratic equation, but it is not linear. And it is because it has a curve here. Let's look at an example. Erin's word processing service does word processing. Its rate for services is $32 an hour plus $31.50, a one-time charge. The total cost to a customer depends on the number of hours it takes to complete the job. Let's find the equation that expresses the total cost in terms of number of hours. I've pulled up Excel just to kind of pull out some information here and be able to kind of show you what's going on through in my head. So we have this service, this rate of charge for services. It's $32 per hour. And then we have this one-time fee of $31.50. So this rate for service is $32. This one-time fee is $31.50. The thing of it is, since this rate of service is based on hours, depending on how many hours, that's going to change. So we need to multiply that by an X. We know that whatever total this is, that's going to be the total for the job. And I'm going to call that Y. So total for the job, I'm going to call that Y. So our equation is going to be Y equals our one-time fee of $31.50 plus our $32 an hour times how many hours they work. So our equation, our linear equation, is Y equals $31.50 plus 32 times X. Now that was just my way of kind of getting my thoughts out so you could see what's going on in my thoughts. But let me show you the solution. We're going to let X be the number of hours it takes to get the job done. We're going to let Y be the total cost to the customer. Since $31.50 is a fixed cost, we're going to have to add that to whatever we get per hour. If it takes X amount of hours to complete the job, then 32 times X is a cost of the word processing only. The total cost is the word processing cost and the fixed cost together. So Y equals $31.50 plus 32X. All right, we have a couple of equations that we're going to work with, and one is our slope, and our other is the slope and y-intercept of a line. That is that y equals mx plus b, or in this case they say y equals a plus bx, where in this case b is the slope and a is the y-intercept. Now, if we have a positive value for our slope, it is upward. If our slope equals 0, it is flat. And if our slope is negative, it is downward. Those are our three types of slopes that we're going to deal with in this area. Okay. Svetlana tutors to make extra money for college. Each tutoring session, she charges a one-time fee of $25 plus $15 an hour for tutoring. A linear equation that expresses the total amount of money is y equals 25 plus 15x. What are the independent and dependent variables? What's the y-intercept and what is the slope? Okay, the independent variable is the x part of it, which would be the cost, the number of hours of tutoring that Svetlana gives. The dependent variable is the y variable, and it's the total cost per tutor session. What's the y-intercept? The y-intercept is the a value, so 25. What is the slope? It is always the value in front of x, and therefore our slope is 15. So let's see what they say. That was my interpretation, but let's see what they say. The independent variable x is the number of hours Svetlana tutors for each session. Yay, we got that right. The dependent variable y is the amount in dollars that Svetlana earns for each session. Okay. The y-intercept is 25. And the slope is 15. For each session, Svetlana earns $15 for each hour she tutors. Okay. So these are pretty straightforward. They're not too terrible when it comes to using our slope. If you've had experience with your y equals mx plus b, you could rewrite it in that way to make it make more sense to you. All right, that's it for this lesson. Until next time, be seeing you.